All right, everybody. So in this video, I'm going to show you how to take a Newman projection and turn that into a skeletal structure, and then from the skeletal structure, we're going to determine whether these are enantiomers, diastereomers, or if they're the same molecule. So again, the question here is how. So the question here is, are these Newman projections enantiomers, diastereomers, or are they the same molecule? So initially, upon seeing these, in my experience, a lot of students are like, oh my God, how do you tell whether these are non-superimposable mirror images or diastereomers of each other just by looking at the Newman projection? But the trick is to turn these into a skeletal structure, assign R and S, and then you state your answer. So in this example, we're going to go ahead and do that. And so what I want to teach is how to turn the Newman projection into a skeletal structure. The way to do that is by looking. So as you all see, I have my little eyeball here. So this is supposed to, this is supposed to be a little eyeball. And what we're going to do here is, so I am saying that I am looking at it straight down that way. So I'm looking at the CH2OH right here. That is what I'm looking at, and that is what is hitting me in the face. That CH2OH right there is hitting me in the face. And as you all know, Newman projections rotate around the CC double bond, and they really only work with they work best with butane moieties, so that CC double bond is going to be at C2C3, and so because of that, I'm just gonna. Honestly, it doesn't really matter if you label this on C2 or C3, but just to stay consistent here, I'm gonna say that this here, right, this thing right here, the CH2OH that is hitting me in the face, I'm just going to put that on C3. All right. So that's hitting me in the face. So what does that mean when something's hitting you in the face? That means that it's on the wedge, right? Because if it's on the wedge, it's coming out of the plane of your board. It's coming out of the plane of your tablet, your computer, your phone, whatever you're looking at. It's coming you and hitting you in the face. So that CH2OH right there is on a wedge, just like so. And actually, just to stay consistent, I'm going to use black. So CH2OH is on a wedge, correct? All right. Now, what is going out of the page as I'm looking at it directly? And again, we have to stay on the same carbon, and the one that's going out of the page, the one that's going behind me, is the one on the exact opposite side, which is that hydrogen right there. That's the hydrogen that's going out of the page. Again, we have to stay on the same carbon, and so that's the one that's opposite to CH2OH. So that's going out of your board or out of your tablet or computer or phone. So that's the hydrogen that's going out of the page. And so what's left is whatever is on the plane. And so what is on the plane of the page here, or of your board? And that's going to be this hydroxyl group right there. So that's going to be on your plane. And so I'm going to simply write that on my plane like that. There you go. All right, now let's do the other group. So what is hitting me in the face here? And as I look at it from this direction right there. And so the thing that's hitting me in the face is this hydroxyl group right here. I'm going to do it in a different color. I'm going to use yellow, gold, and right there. That guy right there is the one that's hitting me right in the face. And again, what does it mean to be hit in the face? Think wedge. So that is the wedge is the thing that's hitting you right in the face. So I'm going to put it on my second carbon here, and that's the OH right there. So what's on the back of the paper, what's going through the back of your tablet or laptop or phone, and it's the one that's on the opposite side of that. So that's what's going back through. You can't see it, and so that's going to be that hydrogen right there. And so therefore, that hydrogen is on the dash, just like so. And by default, that leaves us with the plane, what is on the plane, and that's going to be this aldehyde group right there. And that is That is the group that is going to be on the plane of the paper or of your laptop board or tablet. So there we go. We've now converted the Newman projection into a skeletal structure. Now, very, very easily, we can simply just assign R and S. And that's exactly what I'm going to do here. If you want a more thorough explanation on how to assign R and S using a foolproof method, go ahead and watch one of my earlier videos. In this video, because we're already advanced into the more advanced problems, I'm just going to go through it really quickly. But I promise you all, I'm very thorough in the previous videos and show you how to use this foolproof method of how to doing R and S and never getting it wrong, always getting it correct. So with that being said, I'm just going to really quickly assign R and S. So the first thing I'm going to do is give priorities. That's my first priority. Excuse me. All right, that's going to be my first priority. Trying to circle that. That's going to be this is hydrogen here. It's going to be my fourth priority. Now this is going to be my second priority. And then by default, that leaves this carbon here as my third priority. Okay, and then so doing R and S, we can very easily assign R and S here because the hydrogen is already in the back, and because, as you can tell, we're going to use what kind of motion is that? That is a counterclockwise motion, and because of that, that leaves us with this as a S. That's an S right there. Okay, now let's do it. Now let's assign R and S to carbon or to C3. So that's going to be group 1, priority number 1. That's priority number 4. This is going to be priority number 2. And that's going to be priority number 3. The hydrogen is already in the back, so we can easily do our our clockwise or counterclockwise motion. So 1, 2, 3, 4. As you can tell, this moiety here, or this side of the molecule is going clockwise. So this is going clockwise, and so because of that, that is going to be R. So I am going to label that as R, like so. Alright, so that is R. So we have S and R here. Now what we're going to do is we're going to do the exact same thing with our Newman projection here on the bottom. So I'm going to separate these out like so. So we're going to do the exact same thing, and then we're going to compare the two and see if they're identical or if they're enantiomers or diastereomers of each other. So let's go ahead and do that. So what's hitting me on my face here? It's going to be that hydrogen right there. That hydrogen's hitting you in the face. So I'm going to go ahead and transfer that over to C3 on this side. So that's what's hitting you in the face. It's that H right there. What's on the other what's on the other side of the page, what's going in the opposite direction away from you, and it's that OH right here. So that OH right there is what's going in the back of the page right there, your back of your tablet or phone or computer. And so by default, that leaves us with the plane, and this is going to be what's on the plane, and that is your CH2OH, like so. Again, remember, we have to stay within the same carbon, which is why I'm choosing those 3 points right there. You have to stay within the same carbon. So there we go. We've assigned our designations here. The H is hitting me in my face. The hydrogen is hitting me in the face. The hydroxyl group is going away from me, and the CH2OH is on the plane of the paper. So let's go ahead and assign the groups to the carbon on the left here, C2. So what is hitting me in the face? So as I look at it from this direction, again, I'm looking at it going this direction using my arrow here. And that hydroxyl group right there is what's hitting me in the face right there. So that is going to be on the wedge right there, like so. That's on my wedge. So OH, just like that. What's going away from me, and it's that hydrogen right there. So then that's going to be on my dash. And then by default, this is on the plane, is that aldehyde right there. That aldehyde is what's on the plane. So that's CHO, like so. Now we're going to assign priorities and assign R and S. And as soon as we do that, we'll be able to make a direct comparison. So I'm just going to do my priorities here really quickly. So this is my first priority. This is my fourth priority. This is my second priority. And that's my third priority. Again, we can assign R and S here because the fourth priority is already pointing towards the back. So that's going to be 1, 2, 3, 4, like so. And in this case, it's going counterclockwise. So because of that, go ahead and copy this down because I'm going to undo that. So it's going counterclockwise, and that's going to be S. Awesome. So that's S. Now let's assign priorities on C3. So this is my first priority here. That hydroxyl group is my first priority. Obviously, the hydrogen is always the fourth priority. So my second priority here my second priority here is actually going to be this carbon right there, this entire group. That's my second priority, and my third priority is this CH2OH right there. Now, in this case, our fourth priority is not pointing towards the back. It's not on the dash. So what we have to do is we have to switch that fourth priority with whatever is on the dash. And in this case, it happens to be the first priority. So we're going to do this manipulation. I'm going to say this is number 1 now, and this is number 4. All right, so that's number 1, and that's number 4. I'm actually going to write this a little bit closer over here. This is number 4. Okay, now we can assign R and S. Now our fourth priority is in the back. So it's 1, 2, 3, 4, coming down like that. And so that's a counterclockwise motion, but remember, because we switched the priorities, we have to switch the R and S designation. So as written here, it would be an S, but because we flipped it, we flipped the priorities, it's no longer an S anymore, and now it is an R. So it's no longer an S anymore, and now it is an R. So that becomes an R. And so I'm not going to erase anything. Now we can very, very easily compare these two molecules right here. So what are they? What are they? So we have S, we have R, we have S, and we have R here. So because of that, nothing changed. So these are actually identical. These are identical molecules. And that is your answer. So these Newman projections here, that's what you have to do. You have to switch them. You have to convert them to line structures, to skeletal structures, and then assign R and S and compare them. And because we have S here, and we have S here, we have R there, and we have R there. Nothing changed. So they are identical molecules. If one of them had changed, then depending on which one had changed, it would either be a diastereomer or an enantiomer. Nothing changed again, so they are identical molecules. And that's how to go about solving these Newman projections and these type of problems like this. Thank you so much for watching. Stay tuned for the next video. I really hope this helped somebody.